All right, we picked up with f prime of x. F prime of x was equal to, I can't remember, is it 9 minus 9x over x squared plus 1 quantity squared? So we said we want to find f double prime. Is that correct? So f double prime, we took the second derivative and we came up with negative 18x times x squared plus 1 quantity squared minus that guy, 9 minus 9x squared times the derivative of that, which looks like it should be 4x times x squared plus 1. Is that right? Okay, all over x squared plus 1 quantity squared. So what I'm going to do is I'm going to fourth. Yes, thank you. That's right, because we got to square the bottom. We get to the fourth power. So we are going to factor out an x squared plus 1. And if you notice what happens, Ian ended with this question yesterday. He said, you know, how are we going to take care of that x squared plus 1? When we factor 1 out of the top, it'll cancel with 1 on the bottom. So that's gone. This reduces to the first power. So this is where we picked up. I got f double prime of x is equal to, it looks like we're going to have negative 18x cubed minus 18x. I still have the 4x, so minus 36x. And then negative 9 will be positive 9x squared times the 4x, 36x cubed, all over x squared plus 1 cubed. Are we okay with that? Great. Let's combine like terms. So f double prime of x is equal to 18x cubed, 54x, all over x squared plus 1 cubed. Can I factor that top? An 18x, and I get all over x squared plus 1 cubed. I'm going to do one more thing that people are going to be angry about. Well, I shouldn't prejudge. I'm going to do something that people may be angry about. Okay, all right. X and x minus root of 3 plus root of 3, right? Okay. No. So why do it? I'll show you why. Because we've already talked about this. True or false? The bottom is always positive. True. So therefore, I have to look at where the top is positive or negative. When I factor it like this, I can see exactly where it crosses the x-axis. It crosses at 0, root of 3, negative root of 3. So I'm going to have 0. I'm going to have the positive root of 3. And we have the negative root of 3. It's a cubic that's positive, so it will look like this. This is f double prime. So yesterday, we had the increasing and decreasing and things like that. But we also had concave up, concave down, and then inflection. Where is it concave up? Wherever the second derivative is positive. Where is the second derivative positive? Negative root of 3 to 0. Excellent. Where is it concave down? Negative infinity to negative root of 3, union with 0 to root of 3. When does inflection occur? Yeah, and what I'm going to do is I'm going to actually list it as a coordinate because I'm going to make a graph out of this one. The inflection will occur at an x value of negative root of 3, an x value of 0, and an x value of the root of 3. Can I get rid of all the red stuff off to the side now? Yes. (18x times x squared) be a positive 18x cubed, right? Better? Yeah. Okay, the piece that we're moving to right now is not going to require everybody to be here. So this is a nice spot for actually some people to have to get up and go. You can remind me of our pieces here that we had. We had increasing, we had decreasing, we had max, and we had min. What did we have? Because I don't really remember. So 1 9/2, that is not the interval, but rather the location. Do you see the difference? These are intervals. This is a location, and this was -1 9/2. Okay. So what I'm going to do is I'm going to come up with coordinates right here as well. Take out your calculator. Oh, go away. And I'm going to type in the function. And the function is 9x divided by parentheses. Whoop. Divided by parentheses. X squared plus 1. And I'm going to evaluate this function. I'm going to go to the table, and I'm going to punch in some values. Number 1, if you plug in 1, we should get 4.5, which we do. If we plug in -1, we should get -4.5. I'm going to type in negative root of 3, and I get -3.897. So that's the actual location of one of the inflection points. Are you okay with that? I'll show you graphically here in a second, okay? Now I'm going to type in 0, and I get 0. Now I'm going to type in the root of 3, and I get positive 3.897. Okay, the first two problems on your worksheet, pretty straightforward in terms of identifying max, min, increasing, decreasing, all that. Problem number 3 is the same thing. I just want you to sketch a really accurate graph of problem number 3. And so what I'm going to do right here is I'm going to show you how we can now take what we look at. This thing, you have no idea what it looks like, do you? We're going to graph this guy right here. And I've come up with excellent information that tells me exactly what this graph should look like. It's going to be super cool. And it's going to be super accurate. Watch this sketch. And if you want to do it, you can. You don't have to for this problem. And maybe you want to attach a separate sheet of paper. Maybe we want to find a different room. I don't know. We eventually want to get to the other one. We might have to put the other one somewhere else. But I'm going to look at this data here, and it looks like 4.5. So I'm going to make my x values go out to 4. 1, 2. I'm going to make my y values go to 6. And I just made that choice, okay? Everybody okay with why I chose those points a little bit? So then I have a maximum at 1 and 9/2. 1 and 9/2, which is 4.5. That is the largest spot on the graph. I'm going to label up here max so I remember what happens. And I'll put it in blue so that way I can see it stand out better. And then I have -1, -9/2. So -1 and -4.5. That will place me about right there. And we said that that's a min, right? inflection point happens at, so this is negative 1.73. Square root of 3 is about negative 1.7. So I could go to negative 1.7, which is about right here, okay? This spot right here. And I'm going to go down to negative 3.89. So maybe somewhere right about there. I have another inflection at 0, 0. And I have another inflection at square root of 3 and 3.897. And it does take just a little bit more knowledge about this graph to kind of see what's going on. But I know I have a minimum there. And here's what's kind of cool, is that I'm guessing the graph is going to look something like this. Now, I want to be clear. The problem I asked you to sketch a good graph of on your worksheet, it's a cubic. You know the general idea of a cubic, don't you? Okay? Here's what I know from learning about this graph, and I'll teach you in a couple days. Look at the degree on top. See how it's x to the first? And this is x squared on the bottom. The larger degree is on the bottom, and so it's going to trail off towards 0 on the ends here. If I go to my calculator and I punch in that window and I go x values of negative 4 to positive 4, and I go y values of negative 6 to positive 6, it'll be really interesting to see how close of a graph I get to that guy right there. So just think, before you actually had a graphing calculator, how in the heck would mathematicians try to come up with extremely accurate sketches of that type of stuff? So before, I didn't actually have you find the location or the y value of those. Why did I do it now? Because I wanted you to start to sketch a graph of it. See the difference? Okay. We pause there, turn to your worksheet, try to work a little bit more through it. Wait till the putzes get back. Oh.